Hey there, grade 6 teachers. Let's have a look at some ways that you can connect computer sciences into your space unit. So, you already know that your computer science curriculum contains a lot about abstraction, understanding what abstraction is, and recognizing its applications in projects and in the world. We also know that students are expected to use some block based coding, which is definitely a computer science very specific thing. And they're also being asked to look at the impacts of technology and the potential future influences of technology on the world as well. So, there are some really simple ways you connect this into your space topic as well as your other topics in science and your other units. We know that computer science as organizing idea talks about computational thinking, design thinking, and creativity all being as key processes in the engineering design process. To turn our students into future computer programmers, we need to be looking at all three of these things and how they connect into those skills and procedures that we see specifically at each grade. Let's look first at how we can connect some computational thinking into a whole bunch of skills and procedures here within your space unit. Students are being asked to basically memorize and understand a whole lot about the celestial bodies in our solar system. So, right off the bat, we're looking at the solar system, which is a big thing. It's a huge thing, and we want to decompose it. We're going to break the solar system down into all of its parts. What do you see when you look up in the sky? What's up there in space? Let's break that all out and itemize it down. And so we can start listing all those things, and we can then, start to look at specific attributes of these things. So we've decomposed the solar system, but let's further decompose each of those components of the solar system into its attributes and parts so that we can start to find out some information in order to classify them in a certain way. And as we start to look at those specific attributes, we'll start to look for similarities and differences between them in order to create some types of groupings or put them together. And that's that pattern recognition piece. Let's find some patterns so that we can start, sorting these different components out and determining, where they belong in our whole solar system. What's their purpose, and what do they do for the solar system. And then further, we're going to simplify. Now we've discovered all these attributes and we have these things that belong together. Now how can we lump those together? And this is where our knowledge is coming in. How do we define what is a moon? What's the difference between a moon and a planet? Can we simplify and just categorize all these bodies into one place? All these things are moons. Let's abstract and simplify. And then further to that, we could ask students to write a set of instructions. It could be a set of instructions for something they are actually doing. It could be a set of instructions for a machine for how to classify celestial bodies. We might ask them simply just to order the planets. Any of these activities are working in algorithmic thinking and algorithm design and giving them practice and the skills they need to actually do those block-based coding programs that are required of them as a part of the grade 6 computer science curriculum. If we ask students to interpret models or investigate digital and non-digital resources, I guess not non-digital, but if we're looking at digital resources, now we have the opportunity to draw in these skills and procedures from the computer science that are specifically related to coding and design in society, or how technology has had impacts, or how it may have impacts in the future as well. Talking about how are models of the solar system simplified for us to understand them is going to also teach students about abstraction. So this is an opportunity to really talk about what abstraction is in the context of, well, think about the solar system. When you look at a picture of our solar system, do you think everything that's really in the solar system is in that picture? And then we can determine that, well, no, it's not. There's thousands of stars up there that haven't been represented, and we can't see the moons around some of the planets or whatever, those other things that are missing. And then we can say, well, this is an abstraction of the solar system. It shows us enough information for us to fully understand what the solar system is, but it's been simplified down to make it so that it's much easier to understand. That is a concrete example of abstraction that you can share and work through with your students to help them understand what abstraction is, to be able to eventually identify on their own examples of abstractions encountered in daily life. And talking about how computer technology has changed how scientists study the solar system is going to draw in these topics around discussions about technology and the impacts it's had, and the role of design and coding, because computer systems help scientists track things in space and help scientists look further into space, and we're able to learn much more than we could prior to having those design and coding things available. Asking students to identify and compare technologies. Compare and contrast are highlighted on this page. When we're comparing and contrasting things, we're getting into the computational thinking. We're going to be decomposing and looking at specific attributes so that we can compare them to each other, looking for patterns. That's those similarities. Tossing things that are different off to the side that don't matter. We're abstracting the needless information out. And we could ask students even to write an algorithm. If we're comparing two things, write an algorithm to help a machine or to help another person compare these two things or make that comparison. We're doing the comparison. We're also drawing in the computer science skills and helping students understand them and transfer them into other areas. The final skill and procedure in your space curriculum has students considering what it might be like to live in space. Can see the potential to learn about empathy and practice some empathy skills here as we're considering being the first voyagers in space or being the scientists or trying to figure out ways to get past the barriers that are preventing us from living in space. This gives us an opportunity to pull in the computer science skill around predicting possible impacts of computers, coding, or technology, because probably facilitating space travel or facilitating humans living on another planet someday is definitely going to be heavily influenced by computer technology. So we can encourage students to be a little bit imaginative and creative, apply those creative thinking skills, and think about what computers and technology and coding might do in the future and how it might enable us to eventually live in space. Asking students now to take and create some type of a project in, say, Scratch that shows how they feel a future world where we may live in space could be. Come up with a prototype design for a machine that they think might help us get past some of the barriers to live in space. If they can build something out of block-based programming to demonstrate their ideas or thoughts or their knowledge, they're going to show you that they have this space understanding and also show you that they're able to apply some of those computer science skills around coding. So those are some ways that you can connect computer sciences into your space unit. I hope you enjoyed.